Okay, we have at number 27, we got a cylindrical tank with an open top. They give us the diameter of the tank, and the tank is filled with water. So I'm a horrible artist. I'm just gonna go like this. So like the tank, this is the tank, kind of like a hole in the ground. And then the water, I'm gonna do the water in blue. So here's the water right there. And they tell us that, okay, when the afternoon sun reaches an angle of 28 degrees above the horizon, so we'll say like here's the sun up here. When the the light ray from the sun is coming down like this, bam, hits the water like that. 28 degrees above the horizon is like this. Sunlight ceases to illuminate the bottom of the tank, which means that the refraction that occurs here, the refracted ray, air. So up here we have air. The index of refraction for air is 1.00. And then for water, in here we have water. And then that's 1.33. So the refraction, whenever a ray goes from less dense to more dense, or in other words, smaller index to larger index, the refraction will always be towards the normal line. So this refracted ray is going to go boing, it's going to come closer to the normal line down here, okay, but it's not going to hit the bottom of the pool because they tell us that. It's going to be like this. The ray is going to go boom, right? And if that's the case, this would all be in shadow. Does that make sense? Right, so the ray from the sun comes boom, refracts into the water, but does not hit the bottom because they tell us that when the angle of the sun is 28 degrees above the horizon, the bottom of the pool or the tank of water is not illuminated. Right, so the refraction is going to be boom, it's just going to hit that corner right there. Okay, now how do we solve for? So we're looking for the depth of the water, or the depth of the tank. So we're going to call that y. We know that the diameter of the tank is 3 meters. So all we have to do in this problem is figure out this angle right here from Snell's law. So we'll call this theta 2. The index of refraction for water is going to be n2. This is going to be theta 1. So we don't want to use 28. Whenever you do optics, you're always using angles off the vertical, off the normal. So this is going to be, what is that, 62. That's 62 degrees. So you go, okay, so this is theta 1. We got n1. So Snell's law, n1 sine theta 1 equals n2 sine theta 2. You have everything here except for theta 2. So you plug the numbers in, n1, theta 1, n2, and then when you solve for theta 2, you come out with 41.6 degrees. That's this angle in here. Okay, and the rest of this is a trig problem. So we have we have opposite, right? Opposite, and we're looking for adjacent. So what's that? Tangent. So tangent 41.6 equals opposite, which is 3 over the depth. So then y comes out as 3.38 meters. That's the depth of the water.
Nice.